Welcome to ClickMyProject.com. Now we are going to discuss about the project breast cancer and brain cancer classification approach using deep learning techniques. Now we are going to discuss about the abstract of the process. This process shows how to classify the medical ultrasound images by using the machine learning techniques with the experimental software of the Matlab tool. This main goal of this process is to classify based on the region of interest and to find the input images the breast cancers or not. Whether it is an breast cancer, it will classify the type of the cancers, or else it will detect the normal. This classification of the image is useful to detect the diseases in medical images in every field. In this process especially we are going to use the medical images of the breast cancers only. This working is based on the image processing and is with the help of the machine learning, which is used experimentally simulated in the Matlab software environment. This method is well applicable with the comparison of the machine learning and then the deep learning. Hence, in this process is evaluated by using the three major steps by using the segmentation, feature extraction and classification. Finally, the performance of the process will be evaluated by means of the accuracy, sensitivity and specificity. By using the accuracy, sensitivity and specificity, we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This project consists the modules such as input image, pre-processing, segmentation, feature extraction, classification and finally performance estimation. By this six modules only we are going to play an important role in this project. At first, the input image is taken from the dataset, and dataset consists of lots of images which having the both the breast cancers as well as the non-breast cancer images. After taking any one image from the dataset, the next stage of the project is pre-processing, which is carried by the two steps. One is the image resize, then the another one is the channel separation. In this image resize, the image will be resized into an 256 cross 256, which means the number of row will be the 256, number of column will be the 256 to maintain the aspect ratios of the images. After converting the image into an aspect ratios, we are just do the second stage of the pre-processing, that is the channel separation. In this channel separation, normally the image consists of the RGB band, so we have to extract the red, green, blue channel separately. In case of the input image is the grayscale image, in the sense the image will be remains same. After the channel separation, we just move to the third stage of the step by means of the thresholding and morphological. So hence this method is applied to extract the region of interest from the image, which means the foreground and background. So foreground is the region of interest, background is the unwanted regions. We have to segregate these two things separately. After doing the segmentation, we just move to the fourth stage of the project, that is the feature extraction. The feature extraction is carried by means of the texture based features by means of the algorithm GLCM, that is gray level co-occurrence matrix. After doing the feature extraction, we just move to the fifth stage of the project, that is the classification by means of the machine learning and deep learning. In this classification stage only, we are going to classify whether the input image is cancerous or not. In case it is an cancer, it will shows the result as an cancerous, or else if it is a normal, it is shows the result as an normal. Finally, the performance estimation. In this performance estimation, we are going to estimate the performances like accuracy, sensitivity and specificity. By these three parameters, we can justify our processes efficient. Now we are going to discuss about the running procedure of the project. At first, open the Matlab 2019b and then change the current directory as you want. After that, if you want to execute the process, just right click in the main_GUI.m and select the option run. After the selection of the option run, the user interface will be open like this. So this user interface, you can see the several push buttons in the right side for the controlling actions and several axes and table in the left side for the display purpose. First of all, we have to input the image by clicking this input image button. After clicking the input image, we have to open the dataset. Then we have to select the image from the dataset. After the selection of the image from the dataset, the corresponding image will be shown in the axis 1 with the title of input image. After doing the selection, we just move to the second stage of the project, that is the pre-processing, by clicking the button pre-processing. Here we have 3 stages of pre-processing. One is the image noise filtering, then the second one is the image resize, then the third one is the grayscale conversion. So image noise filtering is applied to remove the noisy particles in the image. Then the image resize is carried out to maintain the aspect ratios of the dimension of the image. After that, the grayscale conversion is carried out to convert the RGB band into one grayscale band. In case already the image is in grayscale image, it will remains the same. After doing the pre-processing, we just do the feature extraction and segmentation by clicking the button feature extraction. So the segmented part is shown here. The corresponding feature values is extracted by means of the GLCM algorithm. So those values are plotted as a table format here. After the extraction of the features, we just plotting the features of the trained data. So the trained data will be collected from each and every image in the dataset. After the collection of the trained data, those data will be shown in this table 2. After doing the feature extraction, we just move to the classification. In this classification stage, it will classify whether the input image is malignant, benign or normal, so whatever it is. So we have to classify, and then the message box will be displayed like this. Finally, we just click the button performance estimation. Now the performance values are shown here like this for accuracy, sensitivity and specificity. Thanks for watching this video.